back on. Okay, good morning, everybody. Let me share my screen again. Hopefully you can all see that, and hopefully corrections in place. All right, so today I wanted to continue with our, to progress our Oak Ridge National Labs stroke DOE New Frontiers RFP response. I have managed to draw up a very quick straw man, working in collaboration with a little bit with Teresa, but I've done most of the work there. And so I wanted to really just go through that today, get the names in the frame in terms of who's going to be contributing to the proposal, and maybe try and get some progress on that. In terms of updates from the government as to when we are going to see the final RFP, which is really the kickoff of 4 to 6 weeks when we need to get a response in. I did get an answer a day or so ago where they said it's with procurement and they don't know when it will be released. So still a bit up in the air, but could be any day, I guess. So we've still got a little bit of time on our hands, but I'd like to get ahead of the curve, and maybe that can make sure that we can get a polished proposal. But before we do that, we do have a number of new attendees. So in our tradition, we like to just say hi to the new attendees and get them to introduce themselves. So if we can do that, let me just look down in the order. Majid, I think you're the first in the list.
All right. Yes. Hi, everyone. I'm with Candu. We are a fabless semiconductor company based in headquartered in Switzerland, but with offices in Europe and US and Asia, Taiwan. We are specialized in high-speed interconnect. We have products in USB, PCIe, CXL, and I'm director of standards, participating in a number of standards, including OCP. Sorry.
Okay, thank you. Thank you. Welcome aboard. The next on the list would be George Scott.
Yes, hi. So George Scott, I'm based in Phoenix, or the Chandler location of ARM, but ARM is the British company that designs the ARM cores that are in, well, almost everything. I joined on about mid last year. I'm a packaging engineer, but working in their overall infrastructure group, trying to really scope out what's coming next.
Okay, thank you. Welcome aboard. And I believe, oh, Brian, would you like to introduce yourself?
Sure. Excuse me. I'm Brian Silverman with Lumineer. Actually, that's spelled wrong.
Yeah, I know.
Okay.
Yeah,
sorry. No problem. No problem. But yeah, we're a design service company here in Silicon Valley. You know, our customers have been the likes of Micron, Samsung, WD, and so forth. We've been focused on storage mostly. You know, we were involved in InfiniFlash with SanDisk WD early on, architecting that and putting the proof of concepts together, largely for open compute for Meta, at that time Facebook, around cold storage. We've done a bit in immersion cooling, developing 16 GPU, 1.5U blade servers to go into tanks using robotic gantries. We've done, products such as 15 blade servers for database acceleration with storage and InfiniBand fabric, redundant switches, high availability, these sort of products. So a little bit of background about us. We're very proficient in thermal engineering, signal integrity, and all the things you need to do to make systems. So that's really who we are. Yeah. Thank you.
Thank you, Brian. And just
and just to note, most recently we've been involved in CXL modules, with one of our OEMs and developing CXL modules.
okay, great. Thanks, Brian. And just Brian's working in collaboration with Teresa, who are one of the companies that have expressed interest in participating here. So at the system integration level. So thank you, Brian, for joining. Okay, so I think that's everybody that's new. Shout if I missed you. So let's move on to the actual proposal. So I did share it in an email I sent out last night. I suspect none of you have had a chance to look at it or read it yet. But so again, this is my first straw man attempt. So I did run through it briefly with Brian in some of the Teresa team yesterday. So we do have some comments on feedback on trying to make things clearer. But essentially, if I briefly go through this, then what I'd like to do is really get everyone to start to go through this in detail, see if it makes sense. Feel free to actually add to it or provide suggestions in terms of updates. And with regards to editing, actually, at the moment, I've shared it openly with anyone as viewing only. But as companies come in, I'd like to give, I think I'd like to start with making it as suggestion privileges so we can actually see who's making the changes, and then we can go through and accept those changes together and progress the document from there. And again, for those of you that are new, we do have a couple of separate work streams where so currently we have a power and thermal work stream on the power and thermal infrastructure, and a system management work stream, an interconnect work stream, and I believe that's the three. And we were thinking of one or two other work streams, but so if you've got a particular area that's where we're getting together. Additionally, on the other week, like next week, we'll be getting together in those three work streams to delve into more detail. But if we can make some progress with this document in the meantime to give us more to discuss in those extra meetings, that would be great. And by the way, if you want to join those extra meetings, if you go to the OCP HPC wiki, you should be able to see the mailing lists for each of those, and you'll be able to jump on those and sign up for them, and you should get the calendar invite, etc., for the attendance. So feel free to jump in here, guys, and obviously this is going to be different variances of how much you guys know. Again, for the new people, probably if you want to get quickly up to speed, my presentation that I did at the OCP Global Summit last October will give you a very high-level view of exactly what we're up to here. It's worth watching the video. There's some animation in there as well, and that'll give you a good background as to the whys, the whats, and the wherefores of what we're trying to achieve. Okay, I'll just to quickly walk through this. In the introduction, I'm obviously trying to set a basic scene here. So I'm saying that the demands of computing are rapidly have been changing pretty dramatically over the last decade, and it's resulted in these seismic shifts in computing architecture. And we've seen that in custom architectures that have been emerging, even from the early days of Facebook, which caused them to create the OCP as we know it today, as well as many proprietary architectures like the Google TPU, NVIDIA DGX, and the Tesla Dojo. And the factors that have been really driving the need for computing architecture innovation have been the increase in power demands, including the delivery and the density of the power, changing the cooling requirements, both air and liquid type cooling, managing processor heterogeneity as we get this proliferation, this Cambrian explosion of compute acceleration. We've got to mix and match those in the good old-fashioned parallel computing way of the 80s and early 90s before Moore's law got in its stride. Then we've got a massive increase in memory capacity and the bandwidth and the low latencies that we need to like this extra memory, especially with we've had that with just data-centric computing, but AI is just given that another exponential boost, as we all know. That's given us exploding bisection bandwidths as well from the cards, where classic PCI cards don't give us enough. So we've gone to these module formats. And we've got this increasing need for domain-specific architectures, this composability where we actually build the computer, we wire up the pieces exactly as we need them for a given application for the most efficient and performant implementation. And finally, we need these new system management tools. CXL is one of them in the composable memory system work group is working on that. But we need a much better system management infrastructure. Sadly, our system management is one of the worst pieces of our industry in terms of it's still 1980s technology in terms of the hardware side of it, at least. And so that's a critical area as well, especially from an HPC machine management or a large machine management. So those are the things that have been changing. And if we look at it specifically from the government HPC, which is obviously what this RFP is all about, if we see what's been going on, the last couple of machines we've seen from the US are the Summit machine, IBM and NVIDIA in Mellanox at the time in 2018, and the Frontier machine, the AMD machine, CPU and GPU. They were really hyper-converged nodes with CPU and a mix of additional GPUs with a very specific interconnect between them. And that was really expensive configurations. And it really, these are so sort of custom machines. They were very expensive and didn't really give much commercial demand, either because of the cost or the fact that, I think another application only needed one GPU and one CPU, or two GPUs and one CPU, or maybe needed an FPGA or something like that, or an AI chip. And so specifically IBM, the Summit machine was a very successful machine. The government loves it. I know that. It's in Oak Ridge. But IBM pulled out. They said they're not going to bother with HPC anymore. It just costs too much. And nobody's buying these machines after they've developed them for the government. So it's not making sense. And so we've literally boiled down. Cray has disappeared. SGI disappeared, and really HPE is the only one left standing. And the government does want more flexibility and more upgradability. So again, those of you that don't know, before this RFP, there was an RFI back in 2022, and we did respond with saying, more of a open, we need an open standard approach. So additionally, these custom machines are being built by incumbents like NVIDIA, and they're not necessarily a good fit for the government applications. And they're also very proprietary, meaning that we cannot be tailored with a mix of heterogeneous processors from different vendors and may suit many, as may suit many applications. So this response is aiming to resolve the above challenges by redefining the open standard computing architecture that addresses the needs of domain-specific architectures with extreme composability through a modular design that can support processors, accelerators, memory, and media from any and all vendors. Machines based on this new architecture will also be easily serviced and upgraded, allowing for a far longer extended service life and significant embodied carbon benefits that will bring. So that's a sort of a introduction to get things started. Any comments? I mean, basically, in discussing it yesterday, we're saying we need a hook to grab the reader, and I'm not sure whether this is a good enough of a hook to grab them, but that we obviously need to get them engaged in this. But so that's what we put together there.
So Alan, this is Munir.
Yeah.
So when I looked at this RFI, right, typically you have, it looks to me it's a more generic, like it doesn't define about what kind of performance is looking for, what kind of system management is looking for, all this information, right? So it's very generic at this time. So is there any high-level guidelines you have that you want us to look into, right? Like, okay, this is the baseline that you should at least attain to, and then anything beyond that, because RFA is not providing that baseline information yet.
So do you mean the RFI from the government, or the
Right,
response?
yeah.
Right. Yeah, no, the point, so yeah, if you read the RFI, the point of the RFI is this is a little bit of research funding, and it's exploratory, sort of R&D type exploration of technologies that could end up being part of a next exascale computer in a 5 to 10 year time frame. So you know, we're obviously addressing a sort of a system view here of all these pieces that are changing, and we're trying to get a new open standard going. So we are covering a lot of bases.
Mm-hmm.
But it doesn't stop people from putting a very specific proposal in of like a, I don't know, let's say silicon photonics proposal all by itself, or and they may fund the ones that look most interesting to them. So the way I've structured this document as well is I think we have a number of critical elements. So we put them in separate sections that we were talking about. Do we do these as separate proposals from our work group, and then in the government said they'd be happy with either separate proposals or one big proposal. The only limitation is 50 pages for the proposal response, which is pretty big. So what I've done is, because we do have least potential interest at this the system integrator level of somebody bringing the pieces together, I've decided to try and present this as one proposal with a number of sections. And it will be I'm hoping that the document will be we'll try and clearly delineate sections and the funding required for each piece, so that hopefully, assuming we get past the gates of government interest, if for some reason we're biting off more, that, you know, they like some aspects of what we're doing, not all of them, maybe they could pick one of the legs and say, well, we're happy to fund that, but not the rest. But hopefully we can get everything funded. Is that sort of?
Yeah, I think just one more thing that I just want to make it clear, right? Because if you look at this government, they did CRACE and that, also the OCP and all those things. But those are like kind of like a standard server architecture, right? But what we are defining here, the reference design here is truly revolutionary, right? It's a very different than what you see totally out there in the server architecture, right?
Yes, that's
is that okay with the is that okay with the government? Because it's a totally different new thing. You know.
Well, I think that's the question.
Right.
That's a very good question, and that was, as Brian will testify from last night's call with Teresa, it is, you know, if we are proposing getting rid of the 19-inch racks and moving to these walls of compute, is that a step too far? And it's the trouble with all of these. I think what I'm trying to articulate here is, if we go with a clean sheet, the beauty is in the simplicity. But obviously, it just looks so radical to everybody, right? This is a double-edged sword. That's because we were saying we could put a number of these modules just into a 19-inch rack mount, but you almost bring back all of the complications of why we got rid of the 19-inch rack. and so, but it might be a nice progress path as we develop this idea. So, and this is one of the challenges is you scare everybody with what we're saying by putting it cleanly, but then you see how beautifully simple it's a bit like the EV market. It's do you just modify what's existing, or do you do what Tesla does and you went to ground zero and you make it far better by going to ground zero? And it's difficult to say to do that middle halfway house, and that's why, if arguably the industry has been making evolutionary progress with around the basic server, as we see, but there's much more radical things going on in the proprietary world. So even companies like NVIDIA and Tesla Dojo and Google TPU, they've all given up to a certain extent. I mean, yes, they've sort of kept the 19-inch rack format, or Cerebras haven't. They've gone to this wafer scale thing. I guess even that's in a 19-inch rack mount as well. But yeah.
But Alan, to my point, that have you is the government people have seen the proposal to a certain extent that they understand that what you're trying to do, right? Because as you said, right, if it's a completely different rack architecture, the whole thing is totally changed. All the cables, cooling system, container system, all those things totally changed. Are they accepting this idea? I mean, they just want to try to understand.
Well, so our RFI, when they wanted a request for information, they saw our RFI. We had a couple of meetings with them, and we see that some of our input is fed back in the RFP. That doesn't mean to say that we have, we're definitely going to get funded on the back of this for sure. But yeah, I think that's, Munir, you are on the button here. Is it too radical for them? Right. But I guess my argument is this is not hard. This is really cheap money, the way we're trying to do this. If we could get people convinced to get their heads around how radical it is. The beauty is in its simplicity. But yeah.
I agree with you. I think if you want to do something radical like this, it's the government is probably the first place you want to try, right? To push this.
Yeah. Well, and the incumbents. I mean, look, you've got to remember, NVIDIA. Whilst they all play nice in terms of trying to make industry standards, NVIDIA doesn't want an industry standard. They love their monopoly, right? So they'll do everything to slow industry standards down. With their participation, or that's what a lot of people argue. So, I mean, yeah, there's two ways of doing this. Either you're a billionaire and you do it like Tesla did it, and I'm not, or you get a community that gets it, and we pull together and make it happen somehow with a bit of, and we need government support to get us to a tipping point where people can jump on. So this is, I guess this is our hope. That we can get this to, if we can get government interest, that we're onto something here. But that's the big if. I mean, I guess ODSA has had, in the chiplet world, has had similar sort of challenges of everybody, the big guys are doing it all themselves, and we're trying to make standards. They're making some good progress, and we're a fair way behind them. But yeah, there's a lot of work to be done there as well.
Sure.
No, but very good points. And if there's another way to tackle this, if we think that we don't want to do a full proposal and we'd rather just do separate proposals for the pieces, I'm cool with that. Or maybe we can put the words in here to say to the government, if the whole thing is too radical, but you like some elements, then we're happy to split this up into elements and fund them separately. We can put
I think, Alan, I think from the server perspective, right? I think what you have, that standard is great, but I think it's too big of a work when you consider the whole infrastructure of the system, right? You're talking about the racks, switches, the whole data center, all those things. So I think we should be a little flexible there. as far as like, you know, if there is a really requirement to put those things in a rack or something, we need to think about that. But at the server side, I think we're fine. I think the reference architecture perspective, we're fine. We may have to have some flexibility there, because when you tackle the whole data center kind of level infrastructure, it's not something people want to change so easily, right? You know, I think a
Right.
server is one thing. You know, we can put it back on and off all the time, but not the whole infrastructure. So we can be flexible, you know, if you want to.
Okay. Yeah, I mean, it's along the same lines as what we were discussing yesterday. So fair, it's a fair point. This background section does delve into the 19-inch rack history and how things have been shrinking in the silicon, but the boxing has been staying pretty much the same, just packing more and more into these 19-inch racks box. So I talk around that there. And then in terms of the scope of this, this is quite an important part in terms of what we are doing here and what we're not doing. And I know we've had a lot of debates around this. But the core focus of this is really pretty simple. It's the system hardware building blocks and the management of this new disaggregated, modular, flexible, composable architecture. We need some system management upgrades so that we can discover what machine is how the machine is wired, and actually manage that machine as well. So the only software aspect that I want in this proposal is the system management software. When it comes to protocols, standards, and the rest, we want a universal interconnect mechanically and electrically so that any transceivers can be wired together. But whether that's PCI, CXL, or Ethernet, or NVLink, or Infinity Fabric, or InfiniBand, or any of the above, basically, or any brand new one from anybody, that's outside of the scope of this proposal. This is purely a Lego brick design of how to plug things together in a much more domain-specific architecture composable way. That's the simplicity of this in terms of we're not inventing new chips. We're going to use people's chips. We're not inventing new software stacks. This hardware, if we've done it right, we will be able to build any existing physical architecture today with these modules, and we will be able to run that, though any software stack, like an NVIDIA one on a DGX box, we will be able to replicate that, assuming we make modules with the same silicon components, and that's the only assumption. Then we'll be able to replicate existing software and hardware implementations. We'll be able to replicate the Frontier node or the Summit node just by simple wiring. And so we can run legacy code, so we can build legacy machines, as well as we can innovate a lot more going forward. So that's a critical one on the scope. And so, you know, apologies, Kevin, in particular, because I know you're on the software side and you're beating that drum. But if you really want to pursue that, I think that's a separate proposal into these guys. Because as Munir has mentioned, we're already doing quite a lot here. Although this is hardware only, and it's quite simple in that it's just so radical that I think we can only tackle this from a scope perspective.
So Alan, I think that from the system management perspective, right? You're saying that we're going to provide the software.
Well, so again, you've missed the last couple of meetings, Munir, in the system management, where we had Mitch managed one of them with Intel, John, what's his surname? Anyway, from Intel, the guy that's heavily involved in all of the current system management software and Redfish and all the rest of it. all of the industry standardization.
I would hesitate to say you can't do the software, because like most systems I've seen fail because they don't have software support.
Yeah,
And we're trying
No,
to
I
cover
think,
that over on the heterogeneous compute thing, where, you know, what we'd like to do is be able to plug in anybody's accelerator and have it work.
And what I was trying to understand is that, you know, if you look at, you know, BMC system management, I think there's a standard is OpenBMC, right? Which is
yeah, exactly. So all
Right.
of the system management software
Right.
that exists today, we would be building on.
So-
we wouldn't redo any of that. It's a
But if you look at,
discovery
if you look at OpenBMC today, Alan, right? So OpenBMC is, you know, I would say, like, you know, if I design a server today, OpenBMC will give you 80%, right? You still need 20% that AMI supports. But the key thing here is that the architecture here is so radical. This is not OpenBMC was designed for. You know, OpenBMC is designed for a standard architecture when you have servers and all those. So there's going to be a lot more, because if you look at OpenBMC, works very nicely with Intel AMI engine, right? We don't have an AMI engine here, and all those things is going to be very much, you know, I would say new stuff. I'm not saying it's impossible to do, but I think we need to put definitely put more focus on that, because just by OpenBMC is not
So to your point there, on the last couple of meetings on system management, Alex Lovell-Troy from Los Alamos National Labs is particularly interested in the software management of these HPC systems. It has to be rewritten with every brand new machine.
Correct.
And John Lung from Intel, who basically oversees all of the open activities from the OpenBMC to all the Redfish stuff. And we've also got the activities going on in CMS, in OCP CMS, on introducing CXL and discovering CXL memory, you know, how things are connected in the CXL memory. So all of that needs to be, so basically what we said in those meetings is we definitely want to be partaking in that software, because we've got all this modularity of when you plug two things together, you need to discover what's plugged together and that they actually do talk the same language, the same protocols, etc., before you turn on the machine. And so yeah, the only software aspects of this would be these higher level aspects. It would sit on top of everything else that exists.
Well,
And so John Lung
it's not quite true, because you're plugging in things which are complex boards, which are computers in their own right these days. So
that's right. So they would have their own BMC as a standalone boot by themselves, but then they would be able to partake as well in a wider. I mean, this is so, again, John and Alex are not on the call, I don't believe so, but they had a good discussion around this area, and I think that's the only piece of software that I think is relevant, and we don't want to reinvent any wheel on the system management side for sure.
Yeah, I think where you win over other people is if it integrates well at the software level.
Well, it will integrate well if you want to build exactly what exists today, a software stack and a hardware implementation.
Well, I think you said yourself that a lot of the stuff we have is like 80s tech. So you might want to think a bit ahead of that.
On the system management side, I'm saying yes, we want to do the new Libra BMC approach to the hardware with Lattice, and
the goal, Alan, the goal is to leverage everything that OCP has. But Alex from Los Alamos has tremendous good insight as a user. In other words, almost no one on the call actually builds and uses these systems. And so the government labs are really the only, outside of the proprietary large five that do everything their own way, is where you get the insight as to how these large systems are actually managed and so on. So has some really good, he's not on the call today, but bringing some good insight as to how the end user of these large systems actually want to manage them. And the goal is to not reinvent the wheel every time they build one.
And I think John gave some insight to Alex on what Redfish are doing.
I think Al Ford also has some some insight of previous work. So I don't want to exclude
All
him
right.
also.
Apologies. Was there a question there for me?
No, just acknowledging that you're an end user coming from the community to contribute. But it is just a general comment. It is a very tall order what Alan's pursuing. It changes a lot. However, in the industry, we know the 19-inch rack server is going to change. Everyone knows this. It's just been a matter of time. And is it going to be done proprietarily inside the large five, and they just go off and do their own bespoke systems? They have the massiveness to do it, to do their own system from the ground up, or will we do something that's more in the open compute that the emerging on-prem will be able to leverage maybe? Anyway, my comments for the day, Alan.
No, thank you. No,
I think the system management software, I'm still thinking it's going to be have to have some kind of a hybrid, because OpenBMC is purely Intel specific architecture. If you look at LibreBMC, Alan, that's kind of like a Power ISA architecture, and we have something not resemble to any of this. So I think we have to, it's a tall order for us. I think we have to pick and see what module we can keep from each side, but there needs to be somebody who have to compile all this together.
No, for sure. I think the system management side is certainly I mean, if you look at that's the unfortunate. We got a long history, and we want to really let go of those real old legacy stuff and grasp the forward thinking stuff. On OpenBMC, by the way, I thought IBM. I'm pretty sure IBM are 100% OpenBMC as well.
Well, IBM goes basically LibreBMC is targeted for IBM, right? That's
the LibreBMC on the hardware side. Well, OCP has adopted LibreBMC and the DCSCMs as well, right? So,
OpenBMC is not. Well, LibreBMC accepted the DCSCM architecture, but OpenBMC is slightly different. It's mainly targeted at Intel and AMD architecture.
Right. Okay.
Because they work with their ME engines somehow. And what we have seen when you do implementation of the BMC in a server, like OpenBMC gives a core, which is great, 80%, or I would say 85%, but it's still the peripheral management, peripheral support is still not fully there. So there's still, I think you cannot just go buy an OpenBMC core, or implement OpenBMC in a server and it works. It works for a single server, but when you took it at a scale level, when you're talking about the data center level, it doesn't work. But when you have multiple peripherals, when you're talking to each other.
Right. Okay. Yeah. Well, I think this is the part of this proposal, and we've got a separate section. Actually, if I fast forward to just to the framework here, this is the sort of structure of how I profess that we should split up the proposal into these sections. So, system management, hardware, and software development is one very important piece. And that's the main one there. The power and thermal, the actual mechanical architecture of how we're building the modules with the thermal management and the power delivery, the efficiency of this implementation is a critical piece. That really is a driver in terms of so I'm talking about a test vehicle where we can actually load slam kilowatts of power in these modules and actually thermally test that we've got a working thermal implementation. Then this universal interconnect where we've got the electrical and mechanicals of being able to talk any protocol, any speed, from an electrical interconnect to an optical interconnect, and so an active near packaged optics, an active cable, an active electrical cable, that we can also conductively cool the ends of that so that we don't need massive cages like QSFP cages for these interconnect, because the power is coming down with the likes of silicon photonics or some LED technology that's coming down the chutes. And then we'll build a number of HPCM modules so that we can build some demo applications along the lines of what the system integrators are wanting to pull together. So yeah, this is the system management is a critical one, and it is a complex part. You're absolutely right. But I do know for a fact that this has been a bugbear of these HPC machines for decades, and for us to deal with this now the whole world is going in this really large scale and even more complex with all the heterogeneity, etc., in the domain specific architecture, modularity, and interconnect.
It's not that hard actually these days. I mean, did you see what Tidal Scale did?
No.
So Tidal Scale got bought by HP, and they were doing virtualization where they would take lots of small machines and turn them into one big one for you.
Okay. Well, that's, I mean, obviously that's great, but I presume that's proprietary. So
yeah, it's gone. But I mean, the thing there is you can do things, very similar things with containers and mapping containers to particular hardware, and it's managed by Kubernetes and stuff like that. I've done proposals for DoD before where I've suggested that. You know, and so there's a lot of stuff there which makes it easy, and I would at least draw that picture in whatever proposal you're making.
Well, so actually, well, coming on to that, I mean, for the rest of this, actually, guys, you know, just to take a step back, but this is where we need the input. So this is a great discussion, and we need to sort of shape these words into that system management section of what we've just been discussing. But just to take a step back here, maybe quickly, given our time, I just went through a methodology of what we're trying to do, and I said it's all about simplicity, going back to first principles thinking. We're just dealing with compute memory, even storage is classed as memory now. And these switches are becoming more like compute, so I've called them intelligent switches and interconnect. You know, these are the three building blocks. And fundamental pieces that we need to feed these beasts are power input, heat removal, and system management. So, you know, when we start to think about a clean sheet of paper and we look at this is the simplicity of what we're looking at. The key difference compared to the 1981 IBM PC that we all still work with today in our servers is we've got tremendous massive power inputs and heat removal requirements that was never needed in 1981's IBM PC. And we've grown warts to deal with that in today's architecture. So that's a problem that we need to readdress from the ground up. So I then basically tried to talk in a bit of I've tried to simplify it down from the complex 3D concepts that we've got into sort of like a pattern approach of a simple, this is what we're trying to do. And then we talk about the computing wall infrastructure, which is, again, to Munir's point, where things get a little bit radical for people to get their heads around, but you know, there's some interesting simplicity there. I've tried to show a simple diagram of the wall with its blind make water and power of how we will do it. So I've kept things very simple there, and then I've delved into how we will split this project up into these pieces. I talk very briefly about each of these sections, and then we've got the sections here where we need the input from all of you guys. So I've got the system integrations section. There's Teresa have been helping out, and Brian's part of working with them. There's AbraWorks. Unfortunately, I don't think Greg or any of his colleagues are on today. That are interested in that. Then on the power and thermal mechanical, I've had some conversations, a lot of conversations with Boyd, including their CTO. Dave, and we had a good meeting last week on in this separate work stream. So Boyd are still jurors out whether they will decide to participate, but they're being very helpful with a lot of input at the moment. Brian from Luminaire, who just spoke earlier. We've got Roger from Program Analog. They do the load slammers and the power designs. And we possibly could do with a power supply company, but we don't have any participants there. So I'm just, maybe we can find somebody that might be interested in participating. On the system management, Munir, as he's been speaking today, is from Lattice, and he's happy to drive this. We've got John from Intel and Alex Lovell-Troy from Lano. So that's the pieces. So anyone else that wishes to jump in here, and Gavin, if you can help out on that, then feel free to put some stuff in there. Then we've got this universal interconnect development. So we've got some discussions going on here. I think Z is on from Amphenol. We had ACES in from in the call in the workstream call last week. Mel from Avicena. Is it Avicena or is it Avicena?
Avicenna.
Avicenna. Thank you.
Yes.
I'll try and remember that. And also Light Intelligence were on with their silicon photonics stuff. So basically, yeah, this universal interconnect where we could even go all the way to sort of co-packaged optics. Could we think of one interconnect solution that covers all of that, as well as this ability to conductively cool a much more miniature active cable implementation compared to today's QSFPs or OSFPs. And then we've got the HPCM module development. So we want to develop a number of modules, so that we can actually configure some demo applications. So can we build some modules? So I've got a couple of names of companies that have expressed some interest in potentially developing an HPCM module. So we need that section filled in for the various modules. And then this is still loose stuff for the concluding. We need to put some financials in. We need to say define what success looks like, and then complete the document. So that's really where we're at. I guess we just had some good discussion around the system management. I'm going to try and put some more words in here to give a sort of a framework to start with, but it'd be great if people can start beginning to either we can either have some more offline calls, or if you feel as though you know where to start to kick off. I guess very briefly on the universal interconnect, based on a discussion we had in the workstream a few weeks ago before Christmas now. We talked about paddle cards versus direct connect cables to interconnect. And I think everyone agreed, on all the interconnect companies agreed, that a paddle card is possible even up to the higher speeds, and that will allow for active implementation. So I sort of began to think that we should be going down a path of maybe leveraging the MCIO based design, but turning that into this universal one, so that we're not starting from scratch. There's enough pins to cover the IOs we need and the power we need. So that was a starting point that we were thinking would be a good place to start, and then frame out everything that would be needed to be done. There are a few other interconnect aspects that we also need to take into account, as well as this universal one, as I've called it, and maybe we can cover that in here as well. Okay, before we wrap up, does everybody understand? And by the way, just because these names that I've put in, if you're not in here, feel free to jump in and say, can you add me to this? And
Hi, sorry, I had to go to another meeting in parallel, so I missed this section. I guess is there sort of a, when you put these names, they're kind of commitments, right? Here to participate.
Well, so basically these are people that have said, yep, we're happy to jump in here and help frame this together. So I mean, yeah, they're commitments in terms of verbal. I don't have anything in blood from anybody.
Right.
But in terms of participation, one of the key things that we've said here is a powerful statement, in my mind at least, to the government, is this is a collaboration of companies, a bit like the ODSA one. It's a collaboration of companies under the OCP umbrella trying to make some open standards that is good for our industry as a whole. This is not just one big player that's going to be our way or the highway, and basically we have to have some proprietary pieces that then have to be reinvented again on the next machine. So even if there's competitors in here that are participating to this, that's the beauty of this, is what pieces do we open up to make sure this is a truly open standard, and what pieces, there are elements of this that could be secret sauce that people can keep for themselves, as long as it doesn't break the ability to have this as a truly open standard, right? A bit like what's going on in ODSA again, where you've got some companies doing some very fantastic contribution, lots of their own IP, but it's very clear as to what pieces are being opened up.
So you could put CANDO's name under the Universal Interconnect as well.
Okay, great. Thank you. That's good. All right, I'll do that.
Yeah, basically we have chiplet, proven technology. Actually, government is, we have government customers both in Europe and in the US.
Oh, and so that'd be great. And by the way, on the Europe, in terms of funding, I mean, this is the biggest one we've attempted to go for. But hoping to get European involvement in this as well for sure. So that'd be great. Yeah, in fact, on that nature, based on what you've already done, Majid, I think it would be good to get you involved certainly on these active pieces in the different types of co-packaging.
The only reason I was hesitant is because I'm involved in a kind of one man,
right? Okay.
Many standards. We have some back-end support, but for me, it's a bit hard to participate too many calls. That's
understood.
And already involved with the Odessa die-to-die, etc. But yeah.
Right. The only other call would be that the interconnect work stream. If that's next week, I believe it's Tuesdays at 8, the same time as this, but next week. So
okay, great, thanks.
And this meeting's every other week as well, every other Tuesday. Okay, guys, we're at the top of the hour. If basically everybody's got view access. If I'm happy to let anybody in that wants to. I didn't want to just open it up to the entire world in terms of editing this, because that could become a nightmare. But I'm happy to open it up to anybody that wants to jump in and get adding.
You put the link in the share in the.
The link is actually in the document in the minutes, which I will publish. Here's the link here.
Okay.
So you'll be able to see and read the response. If you go to the OCP HPC wiki, you'll see I post all the minutes, the Zoom recording. And
okay, great. So those I've seen, but the link to the document. Okay, great. Thanks.
Okay. And the New Frontiers draft RFP is there if you would like to have a read of that to get a better understanding of that. Okay. Oh, I see. If people don't mind, JQ, I see you've just joined. I don't know when you joined, but can I capture your details?
Yeah, I joined about probably 10 minutes into the meeting. This is JQ from Cloudflare. I think I joined a few times before, but just listening in on progress on this. No specific interest, particularly from Cloudflare on HPC yet. Just exploring.
Okay. All right. Well, thank you very much for joining us. For the quick intro. All right, guys. I think that's us. We're past the top of the hour. So thank you all for joining, and look forward to all the contributions. Thanks, everyone.
Thanks, Alan.
Thank you.